Fine. Okay, that's fine. Okay, so yesterday what we have discussed is the virtualization disadvantages, right? And how, because of the disadvantages, how the Docker is evolved. Okay, and we have discussed the difference between monolithic and the microservice architecture. Okay, what is monolithic application? What is microservices? What are microservices? How microservices are advantages, have advantages when compared to monolithic. All these things we have discussed in the yesterday's class. Okay, so as these are demo sessions, I'm not going towards the practical. Okay, because once the practical sessions are going to be started, the demo sessions are going to be ended uh, tomorrow actually. Okay, and Monday the practical sessions are going to be started. Please do remember, Monday the practical sessions are going to be started along with the theory and diagrammatic part. Okay, so let me share my screen. What we are going to discuss today is all about how people use it to deploy, how people are deploying their microservices onto the servers, okay, onto the virtual machines. We are going to discuss actually. Okay, we are going to take a simple example of an application. Okay, it's you know it of having a knowledge of writing the code and all, but we already have an application and we are going to use that application. I'll be also giving that application in your classes so that you can use the same application in order to work with that actually. Okay, so how we are going to discuss today, how people will be deploying their application with Docker and Kubernetes involved onto the servers. Right. So we will be going to this actually today. Okay. Hi, any questions?
Hello.
Hello.
So,
Yeah.
Yes, Shiva, I could not able to see your screen. It's only
No,
just your name is appearing to me.
yes,
no,
same,
it's
same.
not yet shared, not yet shared actually.
Oh,
So
right. It's
give
only
me a
voice.
second.
Okay. Okay.
Yeah.
Got it. No problem. Thank you.
Yeah. Let me go here and let me. I think my screen is visible. Right. So
Sorry.
let me explain you how the people you will be deploying their application to the Kubernetes cluster using Docker involved and the Kubernetes involved to the servers actually. How they are using, how they are deploying in the current scenario. I'm going to take an example of a Spring Boot Java based application. Okay, and I'm going to show you. Okay, let me open a new file, diagrammatic part. Okay, so here, as a developer, what you are going to do is, suppose let's think you are a developer. Developers are going to be developing the code and pushing the code to version control system. What is version control system? It's a GitHub or Bitbucket or GitLab. There are many products available in the market, right? So those are the version control systems. He is a developer, and this developer will be developing the code something like this. Okay, this is the code that is developed by the developer. It's an application code, something like this. They are going to store in the version control systems. They are not going to store in the local machine. They will be using Bitbucket or GitLab or GitHub to store this code actually. Okay, so this is the uh, code application application code. Okay, something like this. Okay, this application code, which is developed by the developer, cannot be directly put on the servers. Okay, if you it is not going to work. Okay, this application code, which is developed by the developers, cannot be directly put on a servers. Actually, this application code will be undergoing many transitions in between uh, developing and deploying that application to the servers actually. Okay, so let me show you. Suppose let me go here. Let me go to One second. This is application, to-do application. This is a Spring Boot microservice-based application. So this is the application code that we have as part of this. You don't have understanding all these things because it's entirely towards the development. This concept here, okay. But you need to understand this diagram, okay, how people use it to deploy. People are deploying their applications on the servers. Okay, so this application code, which is developed by the developer, let's think like that. And this application code is developed by one of the developer, and this application code cannot be directly put on a server. It won't work. Okay, so this application code will be converted. It will be converted. Okay, this entire application code will be converted into a jar file. Okay, jar file. In case of as I'm taking this example of what is this? This is the example of Java. This is a Java based application. Java application. Okay, this application is converted into jar file. Jar file means it's like a zip file. So you can see that here in this application. In this application, we have multiple files. We have this one. We have this file. We have this file. This entirely an application. This is to do is entirely an entire application. This contains many files and folders. Okay, many files and folders. Okay, you can see that here. All these things. Okay, this Java-based application, this Java-based application is converted into a jar file. Jar file. What is this jar file? It's let's just think it's a zip file. Suppose you have multiple files in your laptop. That files need to be sent to your friend. How you are going to send, right? So you are going to convert that multiple files into a zip file, into a compressed format, into one file, and send that zip file to your friend. So in the same way, this entire application files and folders is converted into a jar file. That means all the files and folders of this application is included in one place, that is jar file. Okay, so this application is converted. That's a jar file. In the IT terminology, this jar file is nothing but we call it as artifact. In case of your uh, example, like zip file, that is also an artifact. Okay, compressed, like all the application code, all the application files and folders put together and converted into a jar file. That jar file is nothing but an artifact, we call it as. Okay, so this is a jar file. Okay, something like this, jar file. Okay, how we are going to convert this application code into a jar file? What are the tools we are going to use? Okay, this is a Java-based application. This is Java-based application. We are the most popular, the more popular tools for Java-based application is Maven and the Gradle. Okay, they are the people in the IT who are using Java-based application are going to use Maven or Gradle tool in order to convert this application code into a jar file. Okay, they are going to use a tool called Maven. Here, in order to convert this one, they are going to use Maven tool, MVN or MAVN, whatever. Okay, the two popular tools actually in the market, Maven and Gradle. Okay, MAVEN. Some people uses Maven, some people uses Gradle. Okay, something like this. Whatever they want, they can use that as an option. Okay, so they will be converting jar file. Now, this is okay. This is okay. Previously, this jar file is safely stored in some place. Okay, in some place. People stores this jar file in JFrog or the Nexus. That's one of the repository, we call it as JFrog or the Nexus, or you can also store in AWS S3. Okay, we are going to see that AWS S3. What is that? But yeah, this jar file is safely stored somewhere as a backup purposes. Okay. Previously, without Docker, this jar file will be deployed on a server where the Tomcat is installed. Suppose, let's think there is no Docker as of now. Now, this jar file, previously, there is no Docker. Let's think the first scenario, there is no Docker. Now, how the people use it to be deployed, this application. So this is a server when there is no Docker. This, let's say this is a virtual machine or the server, whatever server. In this server, there will be a Tomcat installed. Tomcat is a web server, okay? Tomcat or the Nginx, whatever. The Tomcat is installed on this particular server, okay? So this Tomcat will be listening on port number 8080, and this jar file will be deployed on top of Tomcat. On top of Tomcat, this jar file means what it contains our application, right? So this will be deployed on top of Tomcat. Okay, so the people use it to access this application using the port number 8080 because the Tomcat will be accessed on port number 8080, something like this. And this one will be sending the request, something like this Tomcat, and the Tomcat will be having the application running something like this. Okay, this is how people need to use in the what is it? If Docker file is there means we will deploy in JFrog. JFrog is a repository. JFrog can store both things. JFrog can store jar file, and the JFrog can store the Docker images also, both things. But yeah, whatever you're speaking, if Docker file is there means we will deploy in JFrog. JFrog is not a deploy. It's a place where you store jar files or the Docker images, not deployments. You are not going to deploy the JFrog actually. So that's the thing actually. Okay. So yeah. Here, this is how the people used to deploy previously without Docker. Okay. They are going to this is a server where the Tomcat is installed, and this jar file will be placed on a Tomcat, and they are going to access the application. So this is not required for us. We are not going to do this. Okay. So just for your information. Now, when the Docker has come, this one is not there. Now, what they are going to do, they have written something called Docker file. Okay, there is something called Docker concept called Docker file, which is very important in our Docker concepts. Okay, this is very important, right? So this is going to be our Docker file. Okay, Docker file. Okay, now this Docker file, okay, we are going to write this Docker file. We are responsible for writing this Docker file. It's not a code, it's not logic, it's not a programming. Okay, it's a file which where you need to write some instruction set of instructions. Okay, so this jar file, which is created from the application using Maven and Gradle, will be included in this Docker file. Will be included in this Docker file. Okay, so this jar file, which is created from the application code using Maven or Gradle, is included in this Docker file. And what is the use of writing Docker file? From this Docker file, people creates a Docker image. Okay, what is Docker image? We are going to discuss the terminology. We have dedicated session for that, Docker terminologies. But yeah, just overview I'm giving how people you are deploying their applications nowadays on the servers actually. Just you need to understand that first. Okay, so this Docker file is converted into a Docker image, something like this. This Docker file is converted into a Docker image. Sorry. Okay, this is a Docker image. This is the Docker image. This is a Docker image. How this Docker file is converted into a Docker image using some commands and all. I'm going to discuss in this in our Docker course. So what this Docker image contains now? Our application only. See here, our application is converted to jar file. What this jar file contains? Our application. And jar file is included in the Docker file, and the Docker file is converted as Docker image. And what this Docker image contains internally, it contains our application only. Okay, that's what the Docker image we are converting. Okay, so now this Docker image should be stored some place, should be stored in some place, because application code is regularly going to be changed. Okay, if any new functionalities need to be included in that particular application, developer again changes the application code and again creates a jar file, and again this jar file included in the Docker file, and again new version of the Docker image should be created. Okay, so, right, so we need to maintain multiple versions of the Docker images. Whenever the application code changes, a new version of the Docker image is going to be created, right? So in such scenario, this Docker image, in order to maintain multiple versions of the Docker image, we will be storing this Docker image into one place. That place is called Docker registry. Okay, so this is going to be Docker registry, sorry, uh, Docker registry, where where we store these Docker images. The place where we store these Docker images is nothing but a Docker registry, something like this. Okay, our Docker image will be there as part of this, something like this. Okay, now this Docker image, which we stored in the Docker registry, is used for deploying onto the servers. Okay, now we will be having a Kubernetes cluster, something like this. Kubernetes, what is a Kubernetes cluster? It's a combination of multiple servers, something like this. This is a Kubernetes cluster. It contains multiple servers, something like this. And we will be having this one. And we are going to have another server. Let's take an example of these 3 servers. And this Docker image will be deployed on this Kubernetes cluster. In case of Kubernetes cluster terminology, we will call it as pod. Let me call the same name. Okay. So in this pod, our application will be running and the request from the browsers will be reaching our application. Okay. So suppose this is our browser. So this is our browser, the Chrome browser. Whenever you search for it, your request will be reaching this application, something like this. It is not directly reaching something like this. There are many components involved in the middle, but yeah, as an initial point of view, I'm saying this. Okay, so this is a Chrome browser. This is a Chrome browser. Okay, so whatever browser it is. Okay, so something like that. Okay, this is going to be the Kubernetes cluster. Okay, something like this. Okay, this is how people are nowadays deploying their applications onto the servers like Kubernetes cluster. If this is one of the application, if you have another application or another Java-based application, so they are using the same way of deploying another application as well. Okay, so this all the things which you are seeing in the diagram, not only these things, few other things are there, integrating with SonarQube and all the things will be automated using Jenkins pipeline as part of this course. Okay, this manual things first we need to understand, then we will be understanding how to do automation for that. Okay, so that's how we do. This is how that is where the Docker file and Docker things comes into picture. Okay, so that's the thing actually. Okay, so any questions anyone has here, please? Is that clear, or anywhere anyone was missing something? Can you put some thing in chat so that I can understand that? Are you?
Please run through that the process and just quickly.
No. Your voice is very low. Actually, can you?
Yeah, just can you hear me now?
Yeah, I can hear you.
Yeah. Just to quickly run through that. Actually, just maybe a minute, just to get through that because I missed a little bit of the previous one.
Oh, okay, that's fine. Okay,
No problem.
let
Thank
me
you.
go through that actually. Here, a developer will be there. Who is a developer? A developer will be developing the application code, and I'm taking the example of Java-based application. Okay, just as an example to take this diagram. Okay, this Java-based application is converted into a jar file. What is a jar file? Jar file is nothing but an artifact where all the application files and folders were included together and created as a jar file. How this jar file is created? This jar file is created using the tools called Maven or Gradle. Okay, so because these are the more popular tools that we have in the market, people uses these tools now to convert this application code into a jar file. Okay, so this jar file which we have is included in the Docker file. This a Docker file is who is responsible for writing the Docker file? We are responsible for writing the Docker file. This jar file is included in the Docker file, and using this Docker file, we are going to create Docker image. Okay, this jar file is included in the Docker file, and we are going to create Docker image out of this Docker file. Okay, this Docker image need to be stored somewhere. Why this Docker image need to be stored somewhere? Because whenever the application code changes, new versions of the Docker images are required to be created. Okay, so whenever the new version of the Docker image need to be created, all the versions need to be stored somewhere. This Docker image where we store is called Docker registry. These Docker images are stored in a place called Docker registry. Okay, Docker registry, see, it might be the hub.docker.com. There is something called hub.docker.com. You need to create an account. I'm going to show you what is that. Okay, that might be the hub.docker.com, or you can use the cloud-based Docker registry like AWS provides ECR Docker registry in order to store your Docker images. Okay, so like that, each and every cloud provider like Azure or the GCP will be having their own Docker registries. You can store your Docker images wherever you want as part of your requirements actually. Okay, all meant for same functionalities. In the JFrog also, you can store your Docker images. Okay, something like that. Okay, Docker registry means it's a universal word I'm using. It can be hub.docker.com, it can be ECR, it can be any other cloud provider Docker registry. Okay, you need to store this Docker image in a Docker registry. Okay, multiple versions of the Docker images will be stored as part of the Docker registry. And this Docker image, which is stored in a Docker registry, is used to deploy onto the Kubernetes cluster. What is a Kubernetes cluster? Kubernetes cluster, just as of now, it's a combination of multiple servers. Kubernetes cluster is a combination of multiple virtual machines or the servers. Combinedly, we call it as Kubernetes cluster. And this Docker image, Docker image, which we stored in the Docker registry, is deployed on the Kubernetes cluster. Okay, so in the Kubernetes terminology, once this Docker image is deployed, that converts into a pod. Okay, this we will call it as pod. We are going to see this pod related information in Kubernetes. I don't want to touch it now because it's a very depth and more concepts are there regarding that. When you deploy this Docker image into the Kubernetes cluster, this Docker image is converted into pod where your application will be running in this particular Docker image, in this pod, something like this. Your application will be running something like this. Okay, so your application will be running something like this, and you should, whenever if you want to access this application, you are going to get a URL for this, and if you use that URL from your Chrome, and your request directly reaches to the application, not something like this. There are some service and ingress controllers are involved in between your request as well as the application pod. All those are included, but as this is overview section, I'm going to just saying this. Chrome, when you when you request the application from Chrome, your request reaches to the application and you are going to get the response back to your Chrome browser. Okay, that's how we are deploying the applications nowadays in the IT industry. Okay, if you have multiple applications, something like this, you will be having multiple Docker files and you will be having multiple Docker registries in ECR to store the Docker images, something like that. Okay, based on the number of applications, you will be having that many number of Docker files and that many number of Docker registries you are going to have actually. Okay, we are going to see this, do not worry, but yeah, this is an overview. You should understand how people deploy their application using Docker and all the things. That's why I've explained this diagram. Okay, is that fine?
Yeah, thanks for that. There's
Yeah.
one question further that for each Docker file, will create a separate pod, or everything is going to be consolidated into one a single pod in a Kubernetes cluster?
No, 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 no. See, you can also create for each Docker file. See, Docker file is converted into Docker image, right?
Mm-hmm.
You should forget about this Docker file. Docker, once the Docker image is created from the Docker file, you know it of referring the Docker file again. Okay. See, this Docker image, with this Docker image, what this Docker image contains? This Docker image contains your application, right? Your application code, right? So this
Mm-hmm.
Docker image can be deployed as multiple pods also, or this Docker image can be deployed as a single pod onto the Kubernetes cluster. All pods will run if you deploy the Docker image as a multiple pods, all pods will run the same application. Why we will be running multiple pods? In order to distribute the number of requests coming towards that application. The load which is coming to the application will be distributed across all the pods. And it will not load on single pod actually. It will not give entire burden on the single pod. The requests which are coming to the pods will be distributed across all the pods because they are running same application. Okay, something like that. If you have another Docker image for another application, you are going to have another pod which will be running another application, something like that. Okay, in the Kubernetes cluster. Did you get that point?
Yeah. Thanks for that.
Yeah.
Is there any limit on the number of pods on each virtual server on
Yes.
Kubernetes cluster?
See, in the Kubernetes point of view, suppose this virtual machine is there, first virtual machine. Okay. This first virtual machine, I'm going to write outside of this. 2 GB RAM is there and two CPUs are there. Two CPUs are there. When deploying a pod, sorry, when deploying a pod, you can specify the amount of CPUs and the amount of memory that is required in order to run this pod in the pod manifest file. See, how you will be deploying a pod is using pod manifest file. You are going to write YAML file in order to deploy this pod. In that YAML file, you can specify the number of CPUs and the amount of memory that is required to your pod in order to run your application. Suppose I specified 3 GB RAM and 3 CPUs, 3 GB RAM and 3 CPUs, sorry, CPUs are required to run my pod, something like this. But this server or the virtual machine or the virtual server has 2 CPUs and 2 GB RAM only. In this case, pod cannot be deployed on this particular virtual machine. Okay. And Kubernetes checks whether any other virtual machine in this Kubernetes cluster is having this much amount of resources. Okay, Kubernetes checks any amount of any other virtual machine has having this much amount of resources in this Kubernetes cluster. If they are having that much amount of resources, pod will be deployed on that particular virtual machine. Okay, pod will be deployed. Suppose this middle this one virtual machine contains this 3 GB of RAM and 3 GB of memory, or the 3 CPUs it contains. Then the pod will be deployed on this second virtual machine. If on the second virtual machine, the pod, the memory and CPU does not contain, means it will be deployed on the first virtual machine. If entire Kubernetes cluster do not contain 3 GB of uh, memory and 3 CPUs, means the pod is going to be pending. So it will not be deployed on that particular Kubernetes cluster. Okay. the answer for your question is the right amount of resources should be available within the Kubernetes cluster in order to deploy your pods. Okay, if the right amount of resources are not there, your pods will not be properly deployed. They will be stuck in the pending state. Okay, so that means virtual machines, the number of pods is until and unless the virtual machine supports deploying the pods, you can deploy that many number of pods onto that particular virtual machine actually. So that's the thing actually. I think the point is clear.
Yeah. And
Clear or
let's say, yeah, it is clear. So
okay.
let's say we have some 100 requests from an application. Since in the example, we have 3 GB of memory and 3 CPU allocated, right?
Mm-hmm,
So, the 3 GB memory is able to handle only, it's an example, let's say 20 requests at a time.
mm-hmm,
So when
mm-hmm.
100 request is coming at the same time, so the other 80 requests be on the pending state until the
No, it
resources
will not be
gets.
like that. It will not be like that in the real time. What the people uses in real time is something called horizontal pod autoscaler. Okay, what that horizontal pod autoscaler does is whenever the high amount of requests are coming, whenever the high amount of requests are coming to the pods, okay, the pod CPU usage will be high. Okay, whenever the high amount of requests, like 20 requests to 100 requests, which you have mentioned, right? There are high, that's a high amount of requests that are coming to the pod, right? So whenever the high amount of requests are coming to the pod for the application, there is a high amount of CPU usage that will be there for the pod, right? So we can define a rule in the horizontal pod autoscaler if the CPU usage of this particular application pods are exceeding 80% or 70% or 50%, you can define that condition in the horizontal pod autoscaler component of Kubernetes. If the CPU usage of the pods, existing pods, are exceeding 50%, the new pod should be automatically deployed onto the Kubernetes cluster in order to serve the high amount of traffic, high amount of incoming traffic. So the new pods will be automatically deployed using the horizontal pod autoscaler. Okay, onto the Kubernetes cluster. We are also going to see the horizontal pod autoscaler on Kubernetes. Okay, but people uses horizontal pod autoscaler when in order to satisfy the high amount of load, high amount of incoming load to the Kubernetes cluster, right? So that's the answer. Is that
Okay,
fine?
got it. Yeah,
Yeah.
got it.
Okay, one question is, Shiva, is actually what is the carpenter role in Kubernetes cluster? I haven't heard so much of carpenter around this area.
Yeah, it provides multiple functionalities actually. One of the functionality I'm going to say,
Mhm,
okay, here I mentioned you this
mhm.
same example again. Okay, I mentioned you if the 3 GB RAM and 3 CPUs are not available within the Kubernetes cluster, okay, then this pod is going to be in a pending state. Okay, this pod cannot be deployed. I have said that point, right? If you use Carpenter, what that Carpenter does, okay, it adds another server automatically. It monitors, it sees that pod is going to be pending state and pod cannot be deployed. Okay, there is no high availability of resources that are there in the cluster. So this pod has to be deployed automatically, or it oh, sorry, it understands that and it automatically adds new server to the Kubernetes cluster to this Kubernetes cluster, and this new server will be automatically added to this Kubernetes. I'm drawing something like this. Do not confuse. Okay, by the carpenter. Okay, something like this. Uh, and this pod will be automatically deployed to the uh, Kubernetes cluster. It acts as a cluster autoscaler. Okay, so this pod will be automatically deployed on this particular node. Okay,
Okay.
this is something called not only this functionality is satisfied by many other things, but yeah, Carpenter also does that. Okay, so cluster auto scaling the cluster. Okay, that means if the right amount of resources or the right amount of things that are not there in the Kubernetes cluster in the current scenario, it automatically launches a new virtual machine or the new machine and automatically attaches that machine to the Kubernetes cluster, and you can work. Your pods can be deployed on the particular virtual machine. Okay, and that's one of the functionalities that is provided by the Carpenter. But yeah, people
Okay.
very rarely use Carpenter, I think. We have multiple customers. No one uses Carpenter, but yeah, that's it. That's fine.
Okay.
No problem.
Okay. Thank you very much.
Yeah. My voice is breaking. Sure. Anyone have any questions? Okay. If no questions, you are required to do some account creations. Let me go here. First account creation is going to be the hub.docker.com. Go here to the new tab and search for hub.docker.com, something like this. Search for this. Okay. So once you search for this, okay, this is the landing page where you are going to land it to. Okay, you need to click on sign up. Okay, you need to give your work, whatever the email or personal account means personal, go to personal account and the email, username and the password and the send, then you can click on sign up. Okay, you can also use OAuth in order to log in with Google, like continue with Google and continue with GitHub. You can also use this, but yeah, instead of, you can also use this, whatever your choice, you can use that in order to create your account. Okay, once the account is created, just try to sign in, click on this sign in, okay, and give your email address when that is given when your account is being created, and click on continue, and the password, right, click on continue, and your Docker registry account will be open. You'll be something seeing all these things. Actually, these are something called Docker registry. For each microservice you are going to have a Docker image. This is one of the Docker image trade app. Okay, so this contains some versions of the Docker images. Okay, so we are going to see the terminologies, but do not worry. What is Docker image? What is Docker container? What is Docker registry? How many types of Docker registries are there? What is Docker daemon? And all those things actually. So all these things, just create this account. It's very simple. Okay, just create this account actually. Okay, one is hub.docker.com. Okay, other thing I request you to create is AWS account. Okay, and I'll be showing in the AWS account in the next classes, but not now. Okay, what I want to do is I want to show you this one. What is that? You also need to install AWS CLI in your local machine, in your laptop. What is this AWS CLI? See, with the with the AWS, okay, with the AWS, the AWS is a cloud provider. Okay, AWS, inside the AWS, there are multiple services. You can use multiple. They will provide multiple services. They will provide a service called EC2 where you can create virtual machines. They will provide a service called S3 where you can store your files. Okay, something like they are going to provide multiple services. Two ways you can interact with those services. One way is using from the console. Go to the AWS account, log into the account, and you can go to the EC2 service, and you can go to from there. We are going to see, but yeah, I'm saying here orally. We can view this. We can view the things from the console. AWS UI user interface in the from the AWS UI. You can view the all the required all the resources or all the servers you can view from there. Additionally, you can also interact with your AWS account from your command prompt, okay, or terminal. If you are using Mac, that represents the terminal, and if you are using Windows, that's a command prompt or the PowerShell. Okay, if you want to interact with your AWS account from your command prompt, you require AWS CLI. Okay, that AWS CLI need to be installed on your laptop. Okay, so install AWS CLI. Okay, go to this page, installing the AWS CLI. Go to here. Okay, you will be having AWS Amazon documentation for it. Okay. Okay, so you will be finding the AWS CLI installation instructions for Linux. Okay, for Mac OS, how you can install, and for Windows, how you can install. Just use just three commands. This one and this one, and I think only two command for version parameters. You can use this. I think most of the people is this command is not required for you. But yeah, only two commands. This one as well as this one. Okay, this is used to check the AWS CLI version once it is installed, right? So just install this AWS CLI on your local machine. Two things I am requesting you to do. One is creation of your hub.docker.com account, and the other thing I'm requesting is to create and to install AWS CLI. Okay, just let me share this to your chat. Yeah, some of the Linux basics are covered, like how to use the commands and all the things. Okay, so I'm not going to use PowerShell and all because DevOps entirely deal with the Linux, but not the Windows. Most of the DevOps activities are dealing with the Linux actually. Okay, so if you in your industry also, Kubernetes or the Docker you will be using as part of the Linux machines, but not the Windows machines mostly. Okay, so it will be 8 to 9:15 actually. Okay, how much time will be dedicated for the classes? Each class is 8 to 9:15. Yes, classes will be from Monday to Friday, not till Saturday. Any weekends workshops will be there. Yes, this weekend only workshop is there. If you go to the DURGASOFT website, you are going to find, yes, I'm going to conduct workshops based on different concepts. Yeah, it might be the AWS and it might be the whatever. Okay, not the class timings, I mean labs. Okay, what is this? No, no, no. It does not like it is not like that. Huh? Okay. See, one day the class entirely might be a lab. Okay. One day the half of the class might be lab, some half of the class might be the theory and diagrammatic part. So it depends actually. It depends on the concept we are learning on that particular day. Okay. So that's how we do. Okay, we can meet you in institute or the phone if we want to talk. Yes, you can meet me in the phone, but not the institute. For any doubts, what we are going to do is we are going to create a Slack channel or any, let's think either Slack or the Telegram group, so that you can you can post your questions there, and whenever you are practicing out of hours, out of the classes, right? Then we can solve your questions in that particular Telegram group. If required, we are also going to connect to you uh, to solve your doubts actually. Okay, something like that we are going to do. We are planning. Last batch also we did it in the same way, and this batch also we are going to do in the same way. Fine? Is that fine? Respond. Is that fine? Okay. You can one second. Go to DURGASOFT. You can find the syllabus here. Where is that? Yeah. This is going to the syllabus. This is going to be the syllabus. Okay, so that's the thing. And let me give you the details for the registering the course actually. If you are interested, please go ahead and register for the course. And please do remember, tomorrow is the last demo class that we are conducting. And from Monday, the link is going to be changed, and you are going to get a new link in order to join to your mail IDs. Please do remember that, and please do check your mail IDs. That's a request from my side. And these are the details which I have put in the chat. If you are interested, please go ahead and register for the course. And that's the thing. If you have any questions, you can ask. If not, we can meet in the next class, that is tomorrow. Any questions, please?
Yeah, hi. So actually, we are not going for. I mean, basically, myself is not going for the full course. I am going for your second one, which is actually Docker and Kubernetes. Is actually both of these courses are together?
Yes. First, we are learning about Docker and Kubernetes, and then we will be changing the link for the other two parts, Jenkins and AWS.
Okay. So if
That's how we
time
do.
permits, we may go. I may go or may not go. So first, initially, I'll go for myself. So that will be. So this initial part of the training will be focused on the Docker and
Docker and
Kubernetes.
Kubernetes.
Okay,
Yes.
no problem. Thanks for that.
Yeah. Okay.
Yeah. Thank you.
Thank you. Thanks for joining, everyone. We'll meet in the next class, that is tomorrow. Okay. Thank you. Bye.